Welcome everyone. So in our previous video we have completed practice set 6.1. Okay, and now let's start today practice set 6.2. But before starting 6.2, let's understand some terms. Okay, so practice set 6.2 is totally based on application of trigonometry. Okay, so here in previous exercise we have solved the sums related to the trigonometric identities and ratios. So here we will solve the sums related to the application of trigonometry. Okay, so student, sometimes many here it is given that many times we need to know the height of a tower, building, tree, or distance of a ship from the lighthouse, or width of a river, etc. Okay, so this trigonometry helps us to find the distance and a height of a particular object, or distance between the different objects. Okay, so we will solve the sums related to the application based of on trigonometry. Okay, so here to solve this type of a sum we need to know the terms. Like first term here, let us study a few related terms, application of trigonometry. Okay, so first related term is line of a region. So what is this line of a region, student? If the observer is standing at the location A, okay, so here it is observer is standing at a location A and looking at an object B. So here it is object and here observer is standing. Okay, so then the line AB will called as a line of a region. This is a common line of a region. Okay, so if here observer is standing and here B, that is above or below the line object is there. Okay, so it is called as a line of a region. All right, and second is the angle of elevation. What is angle of elevation? So if an observer at A, okay, observer is standing at point A, observes the point B which is at a level higher than AM. Okay, it is this is a horizontal line. AM is a horizontal line, and if observer is standing at point A and looking at point B, so this will call as the angle of elevation. Okay, that means from level higher than the horizontal line, the angle made by the observer, it is called as the angle of elevation. Okay, then angle BAM is called as the angle of elevation. And third term is angle of depression. Now what is this? So if an observer at A, this is observer at A, observes the point C which is below the horizontal line, it is below the horizontal line, then this angle is called as the angle of depression. Okay, so student, angle of elevation, it is angle which is higher than the horizontal line. So this is angle of elevation. And angle of depression, when we see below the horizontal line, the angle formed is called as the angle of depression. Okay, so these are the related terms to solve which will help us to solve the practice set 6.2. Alright student, let's solve practice set 6.2. Okay, now students, to solve the practice set 6.2, one more important thing you should know, that this table you should remember. Okay, this table you should remember so that you can easily solve practice set 6.2. Okay, because here the values of sine theta, angles, different angles of trigonometric ratios are given, that is sine theta, sine 0 degree, sine 30 degree, like it is given. Okay, so this you should remember so that we can easily solve practice set 6.2. all right, now let's solve question number 1 here. Now question number 1 is, a person is standing at a distance of 80 meter from a church looking at its top, and the angle of elevation is of 45 degree. Find the height of the church. So first of all, here it is we will make a rough diagram. Okay, so a person is standing at a distance of 80 meter. All right, so here just draw a diagram. For suppose this is an observer A, it is standing at A and it is at a distance, here it is a church at a distance of 80 meter. All right, so this is a distance of 80 meter, and then it is said that it is observer made an angle of elevation that is 45 degree. All right, so this is line of region and this is a horizontal line, and here it is For suppose this is A, C, B. So at point C, church is there. At point A, observer is there. And observer made an angle of elevation that is 45 degree, like in this way. Alright. And here we have to find out the church, height of the church, that is BC. Okay, so let's write this in statement. So first we will write, suppose BC is a church or height of a church. Okay, and we will assume that its height of the church is h meter. Okay, this is h meter. So in triangle ABC, here I am giving the name of a triangle ABC. In triangle ABC, AC is given as 80 meter and BC we have assumed as h meter. Okay, so these are the dimensions and we have to calculate height or h. Alright, so student, here angle A is 45 degree. That means here adjacent opposite side we have to calculate. This is opposite side and this is adjacent side. Alright, so which trigonometric ratio we will use? We will use tan trigonometric ratio, that is tan theta. Alright, so here we will write tan theta is equals to opposite side upon adjacent side. That means opposite side of tan theta is BC and adjacent side is AC. Alright. Now here angle theta value is given, that is 45 degrees. So we will write here tan 45 degrees equals to BC. Alright. So BC we have assumed as h meter and the value of AC is given as 80 meter. Alright. So from the table the value of 45 degree is as 1. Alright. This you can find out in the table which is given in your textbook. Okay, so the angle value of angle tan 45 degree is 1, so it is h upon 80. So here we will write h is equals to 80 into 1, that is h is equals to 80 meter. Alright, so you will write in the statement that height of the church is 80 meter. Alright, now let's solve question number 2. Okay, now student, question number 2 is, from the top of a lighthouse, okay, from the top of a lighthouse, an observer looking at a ship makes an angle of depression of 60 degree. Now here in first we have angle of elevation and in second we it is angle of depression is given of 60 degree. Okay, and if the height of the lighthouse is 90 meter, then find how far the ship is from the lighthouse, and here root 3 value is given. That means here we have to find out the distance between ship and a lighthouse. Okay, so let's make a diagram first. So here it is, we will make the diagram first. So I am drawing in this way. Okay, so here an observer is standing at point A and here it is looking at a ship which is at point C. Here it is, ship is there and this point will be point B, an angle of depression. So here this angle will be angle of depression. Alright, and it is our horizontal line and we have to calculate the distance. Here it is lighthouse and we have to calculate the distance between lighthouse and the ship. That means we have to calculate BC. Alright, and this AB is given as, this is given as 90 meter. The height of the lighthouse is given as 90 meter. That means AB is 90 meter. Alright, now let's write in the statement. So student, we will first write as AB. What is AB? AB is a lighthouse. Alright, and the height of AB, the dimension of AB is given as 90 meter. Okay, this is given in question only. So the angle of depression, okay, so here it is given that angle of depression, or we can angle of depression is equals to 60 degree. It is given. And here what is the horizontal line? AM. This AM will be horizontal line. Okay, this will be AM is a horizontal. AM is horizontal line. Alright, angle MC is equals to MA. This is 60 degree, which is of elevation. Okay, and here we will at point C there is a ship. So at this point ship is there, and here angle MAC. Alright, angle MAC is equals to angle ACB. This angle MAC is equals to angle ACB. Why? Because these are the is equals to 60 degree, and these are the alternate angles. So alternate angles are always equal. Alternate angle will be equal. So if this is 60, this will also be 60 degree. Okay, this and this alternate angle. So these are the 60 degree. And here BC we have to calculate, and we will assume BC as x meter. X meter. Alright. So in triangle ABC, alright, now student, in triangle ABC we will write all the dimensions. So in triangle ABC, AB is equal given as 90 meter, and BC we have assumed as x meter. Alright, and angle of this angle ACB is equals to 60 meter. Okay, so what we have to find out? We have to find this side. Alright, so again here opposite side is given and adjacent side we have to find out. That means we will use the trigonometric ratios tan only. Okay, so here we will write as tan theta is equals to opposite side upon adjacent side. That means tan theta value is given as 60 degree. That means tan 60 degrees equals to opposite to 60 degree is AB. Okay, this AB upon BC. Alright, so from the table tan 60 degree value is root 3. So this is root 3, and value of AB is given as 90 meter, and BC we have assumed as x meter. Alright. So here we will do the cross multiplication, that is 90 upon root 3 is equals to x. So this x will go here and root 3 comes in the denominator. Now let's solve further. So we get x is equals to 90 root 3. Okay, so if in denominator we have the root 3, so we will do the rationalization. Okay, so after rationalization we get x is equals to 90 root 3. We will multiply and divide by root 3 only. Okay, so this will be x is equals to 90 root 3, and root 3 multiplied by root 3 becomes 3. So it will cancel. 3 1s are 3, 3 3s are 9, 0 will be 0. Okay, so x is equals to 30 root 3, and student here root 3 value is given in the question, that is 1.73. So just we will multiply 30 and root 3 value is given, that is 1.73. So after multiplication we will get the value as 51.9 meter. Alright, so this is a this is the height of the lighthouse. Now let's solve question number 3 also. Alright. Now student, question number 3 is given as two buildings are facing each other. Alright. Two buildings are facing each other on a road of a width 12 meter. And from the top of the first building, which is 10 meter high, the angle of elevation of the top of the second is found to be 60 degree. Alright, and what is the height of the second building? So let's solve this one. First we will draw the diagram according to the question. Okay, so it is given that two buildings are facing each other. That means one is a smaller building and one is taller building, because height of the smaller building is given as 10 meter. Alright, 10 meter, and another building height is given as 12 meter. Alright, sorry, width of the road is given. That means this is given as 12 meter. And from the top of the first building, that is from the top of the first building, the angle of elevation, it is given as 60 degree. That means this will be horizontal line, and this is angle of elevation, that is 60 degree. Okay, and what is the height of the second building? So this is this height of the second building, a greater building, we have to find out. So let's give a naming. This will be point A, B, C, D and this point, that means this point will be E point. Alright. So let's solve this question. So student, if we will look at the question, this A, B, D and E, this parallel. Sorry, this will become rectangle. Okay. So let's write the statement. So this will be solution. So there we will write there are two buildings. There are two buildings, that is AB and CD. Okay. So CD are two buildings, and width road is given, width of a road, that is BD is equals to 12 meter. Alright. And let the height of the second building or CD is H meter. Okay. So here write as CD. Okay. So CD equals to this CD will be equal to E plus ED. C plus ED. Alright. So AB, here we can AB is equals to ED is equals to 10. Okay, this AB becomes equal to ED. This will become 10 meter because AB is parallel to ED and A is parallel to BD. So this will be equal, and BD is equal to AE is equal to, why? Because AB is parallel to ED and AE is parallel to BD. That's their value will be also equal. Okay. Now we will write here in triangle ACE. That is ACE in this triangle. Okay. This one, this triangle. So angle CAE, it is given as angle of elevation as 60 degree and AE is given as 12 meter. So again here this adjacent side is given, opposite side we have to calculate. So here we will use tan theta only. So tan theta opposite side upon adjacent. So value of tan theta is given, that is tan 60 degree is equals to opposite side is CE and adjacent side is AE, and from the table the value of tan 60 degree is equals to root 3 and CE we will calculate, and value of AE is 12. So CE is equals to 12 root 3. Okay, so this CE we get as 12 root 3. Now we have ED also and CE. Now we will add the two ratios. We will add the two values to get the CD. Okay, so CD is equals to CE, that means this CE is equals to, CD is equals to CE plus ED. So value of CE we get as 12 root 3 and value of ED we have as, okay, value of ED we have 10. So 12 root 3 plus 10 meter. So this is the height of the second building. Okay, now let's solve question number 4. So question number 4 is two poles of heights 18 meter and 7 meter are erected on a ground. Okay, that means two poles of height 7 meter and 18 meter are erected on a ground, and the length of the wire fastened at their tops is 20 meter. That means from 7 meter, that means two poles like here. I've made a diagram, two poles, that is first pole is AB of height 7 meter and second pole CD of height 18 meter are erected each other on the ground, and the wire, okay, the wire is fastened at their tops in 22 meter. Alright, and we have to find out the angle made by the wire with the horizontal line. That means we have to calculate here angle of elevation. So here I have written there are two poles AB and CD. I have written all the given data, and okay, so AB here angle of elevation theta we have to calculate. And here student, if you can observe here AB, D and E, it is an rectangle. Okay, so if this is rectangle, so AB will be parallel to ED, okay, and BD will be parallel to A. That means their ratio will be, their heights will be equal. All right, so here we will write CD is given 18, okay, and CE, that means this we want this now. So we will write here CD is equals to CE plus ED. All right. So this ED becomes 7 meter. So here we can get the value of CE, because this value of CE we require to calculate the angle of elevation. So CE is equals to CD minus ED. Okay, that means CD value we have as 18 meter minus ED value we have 7 meter. That is 18 minus 7, it will be 11 meter. Okay, so value of CE we get as 11 meter. That means this is 11 meter. So here student, here hypotenuse value is given. This is 90-degree angle. Okay, so here hypotenuse value is given and opposite side value is given, so we can easily find out the angle. So which angle we will it will be sine angle, opposite upon hypotenuse. So we will write here sine theta is equals to opposite side upon hypotenuse. All right, so sine theta is equals to opposite side is CE and hypotenuse side is AC, and theta we have to calculate. So C value we get as 11 meter, and AC we have as 22 meter. That means 11 1 is 11, 11 2 is 22. That means sine theta we get as half. So from the table, if we will look the theta value of half, sine theta half value of sine angle, it is 30 degree. So sine theta is equals to 30 degree. That means the value of angle of elevation is equals to 30 degree. All right, now let's solve question number 5. Okay, so question number 5 is a storm broke a tree and the tree top rested 20 meter from the base of the tree, making an angle of 60 degree with the horizontal. Find the height of the tree. Okay, so here I have made a diagram of question number 5, and here according to the question I have written given information. Okay, so student, in this diagram AB, this AB is the height of is a tree, and due to storm it broke from point D. Okay, so it broken from the tree top, that means the tree top, that is AD, is broken, and it will fall here also. Okay, and the broken part made an angle of 60 degree. That means this part only made an angle of 60 degree with a horizontal line, and AD is equals to CD, because this is the broken part of tree top only. Okay, now let's solve it, and we have to find out the height of the tree. So first we will in triangle BCD. Okay, in triangle BCD, BC is given, that is 20 meter. This is BC base, and angle DCB is equals to 60 degree. Okay, so if angle 60 degree is there and 20 meter, it is adjacent side is there, and we have to calculate the opposite side. Okay, we will first calculate this, then if we have if we will find the BD, then only we are able to calculate the height of the tree. Okay, so first we will find out BD from the triangle BCD. So it will be sine 60, sorry, tan theta, that means opposite upon adjacent side. So tan theta is equals to opposite upon adjacent. All right, so opposite side is, that means tan theta is equals to opposite side is BD and adjacent side is BC. So tan 60 degree, theta value is tan 60 degree, and value of BD we have to calculate, that is BD, we will write BD only, and BC it is given as 20 meter. Okay, so from the table the value of tan 60 degree, it will be root 3. Root 3 is equals to BD. BD will be 23. Okay, so BD we get as 20 root 3. Now we get the value of BD, find this. Okay, now after getting the value of, we will now find out the hypotenuse value. Okay, so if we will get the hypotenuse value, then only we are able, we will do AD plus BD, so we will get height of AB. All right, now here we will use the sine 60 degree. Okay, we are using this triangle only, that is sine 60, that is hypotenuse upon this one. So sine of 60 degree is equals to opposite side upon hypotenuse. Okay, so from the table sine 60 degree value is root 3 upon 2, and opposite side is BD and hypotenuse is DC. Okay, opposite side is BD and hypotenuse is DC or CD. So the value of BD, just now we have calculated, that is 20 root 3 upon DC will be as it is. Now we will write here DC is equals to 20 root 3. So this 2 will go here in numerator and this root 3 will comes into the denominator. Alright, now what we will we will cancel root 3. So DC value is equals to 40 meter. Okay, now we have BD also, and we have this DC is 40 degree, then AD is equals to DC, so AD will also 40 degree. So AD is equals to DC is equals to 40 meter. Now for AB, that is height of the tree, AB is equals to AD plus BD, that is 40 plus 20 root 3 meter. Alright, so this is the height of the tree is 40 plus 20 root 3 meter. Okay, now last question from this practice set. So this is question number 6. Okay, so in question number 6, it is given that a kite is flying at a height of 60 meter above the ground, and the string attached to the kite is tied at the ground, and it makes an angle of 60 degree with the ground. And assuming that the string is straight, find the length of a string, and root 3 value is given as 1.73. Alright, so here I have made a diagram according to the question, that is ABC. So this is there is a kite at a point A. Okay, so this is a kite at a point A which is 60 meter above the ground. Okay, and the string makes an angle of angle with the ground, that is angle of elevation is 60 degree, angle ACB is 60 degree. Okay, so student, we have to calculate the this AC distance we have to calculate. Okay, so here opposite side is given, this is an angle, and this is opposite side to the angle is given, and hypotenuse we have to calculate. So we will use which ratio? We will use sine theta. Alright, so here we will write, that is in triangle, first we will take triangle ABC. So triangle ABC we will use sine theta. Okay, so sine theta is equals to opposite side upon hypotenuse. So opposite side is AB. This is opposite side AB, and hypotenuse is AC. So sine theta is angle 60 degree, and AB value is 60 upon AC, and from the table the value of 60 sine 60 degree is root 3 upon 2. Okay, so this is root 3 upon 2 is equals to 60 upon AC. Alright, so therefore AC is equals to 60 multiplied by 2 upon root 3, numerator denominator. Alright, now let's solve this. That is AC is equals to 60 into 2 upon root 3. So wherever there is a root 3 like number is there in the denominator, we will do rationalization of root 3. Okay, so it becomes 60 into 2 root 3 multiply and divide by root 3. Alright, so 60 into 2 into root 3. Now root 3 multiply by root 3, it will become 3. Okay, so it will become 40 root 3, and root 3 value is given, that is 1.73273. So after multiplication we will get as 69.2 meter. Okay, so you will write in the sentence that the length of is 69 meter. So that's this video. Student, I hope you all have understood how to solve this type of a sum.